conference. My name is Terry Coda. I am one of the conference organizers. We're going to get started very shortly here. I just wanted to say a few words at the beginning. First off, wanted to thank all of the various sponsors for the conference with whom it would not be possible. I wanted to encourage you all to have a look at some of the offerings from the ACM. Of course, the conference is sponsored by the ACM, the Association for Computing Machinery, which is one of the largest academic publishers in computer science, also effectively the organization for computer practitioners. And so there are a lot of interesting offerings they have at the ACM website that you can have a look at. And one of the other things that they do, of course, is put on conferences like this. Don't have too much more else to say about that. As I say, I want to get right into the talk, so I want to welcome you to the conference. And our first talk is going to be given by Adam Arsenault from Hootsuite, and he is going to be talking about how they manage microservices at Hootsuite. So without further ado, Adam.
Hello. Let me get my slides up. For some reason, my internet died right when I plugged in. Of course, that's always the way it works, right? Sorry, I'm just trying to get this set up properly. Where is my mouse? Sorry. All right, let's get started here. So, good morning. My name is Adam Arsenault, and I'm a software developer on the mobile web and APIs team at Hootsuite. This morning, I'd like to talk to you about how we manage our growing microservice landscape at Hootsuite. So what is Hootsuite? If you haven't heard of us before, we're the world's most widely used social media management platform. We have over 10 million users, and we're trusted by 800 of the Fortune 1000. Our platform brings together social networks and integrates hundreds of business applications. So what we're going to talk about today, we're going to talk about a brief bit about our road to SOA, kind of like some of the things that we encountered when we moved to a service-oriented architecture. We're going to talk a bit about service graphs in general, just to kind of talk about some problems. We're going to talk about an API that we built and a tool that we use called Voltron. We're going to give a little demo, hopefully, if we have time, and talk about some lessons learned. So Hootsuite was founded in 2008, and like most startups, we kind of started off as a monolith, so like one giant application. We deployed our code to production in one application. As our team grew, this wasn't very effective. We started to grow really quickly. We went from a dev team of 10 people to over 100. So as we started to do that, we noticed a lot of problems with our application being a monolith. And we were also experimenting with continuous integration. and that caused a bunch of problems as well. Today, we have over 20 services in production, and that seems to be growing all the time. So during our rapid growth, one of the things that our CTO was talking about all the time was Conways Law. And the idea here is that organizations which design systems are constrained to design copies or systems which are copies of their organizational structure. So the interesting thing here is that as you go to break up your company into different groups that are building systems, you want to kind of break them up into groups that are going to model what the product you're building. So as we did that, we broke out into these teams. So we had an engagement team, a publisher team, an analytics team, a mobile team, a platform team, tools, and labs. So each of these teams really has their own goals, their own set of features, and their own autonomy. They work kind of in silos. They communicate with each other, but not as much as we did when we were working in a monolith. So as this happened, we basically were building levels of abstraction around each team and kind of hiding internals from other teams. I mean, that's kind of what the goal of services, right, is you want to take away some of the complicated stuff. But that can cause problems, especially when your team is growing fast. So as we were splitting up and we were doing this, we noticed all the time that we were having all of these basically breaking issues. So this kind of caused two major types of issues. One of them would basically slow down our development velocity quite a bit because something would be broken and we really couldn't tell what it was. And the other one would just be like production issues, right? And obviously we don't want to have production issues because that affects our customers. If our customers aren't happy, then our business doesn't work. So the big two kind of issues that we saw, the main examples are integration failures. So the workflow here is a dev, they're working on their own stuff. They go and they merge their changes into master. So we have like a build pipeline for our main product. And when these changes go into staging, what they would notice is tests that passed on a development environment wouldn't pass in staging. So this would cause panic, right? All of these other people, developers, are merging code into, they're going into this continuous integration environment, and now the pipeline is frozen because stuff's failing and we don't know why. Developers often became really panicked. They're like, is this my code? Is it my code that's a problem? We didn't really have great ways to tell the difference between, say, like a code failure in an integration environment and an integration issue. So this would cause lots of freezes in our release pipeline and a long time to diagnose. The second type, like I mentioned before, is really just production downtime. So something goes wrong in production, a bunch of, we have monitoring our services, a bunch of alerts go out to all of these teams. If something goes down that's shared by a lot of teams and services, everybody's getting alerts. Everybody's kind of in a panic and no one really knows what the root cause of the problem is. So really, I think the biggest problem here is visibility. We didn't have a really great set of tools beyond the alerting that helped us answer some of the deeper problems, like what is the root problem of a cause? And this went into like bigger questions, like how is your architecture built? Things like, how many services do you have in your application? So if you have a JavaScript developer who's gone and merged code in production, and that's gone in continuous integration environment, and now their tests are failing, or integration tests are failing, they don't really know that service 5 could be down in the integration environment. So we're having a lot of challenges basically having visibility into our internal environment. So now I want to talk a little bit more about just the service graph in general. So yay, we have a monolith. We have this app. We have one node, right? We just have one thing. It's pretty easy to reason about. Something goes wrong in that one thing. It's pretty easy to kind of dive down into that one thing and start to reason about it. Yay for monoliths. Then, we might get to something like this. So we're breaking our monolith down. We're slowly starting to create services. So we have 2 services here. Still pretty easy to reason about, right? You have one app and you have 2 services. Okay, this is getting a little bit more complicated, but still pretty easy to reason about. We don't really have very many like inter-service dependencies yet. Still pretty easy to understand. But once you start to add, once you have the same amount of services and you start to add inter-service dependencies, then it becomes a little bit harder to reason about. So let's add a few more services in there. Okay, great. So this graph is starting to get a little bit more complicated, right? So you can see here we only have 7 services, but because of all the interdependencies, if one thing near the bottom of the graph goes wrong, it's going to affect a lot of other things. So in this example, okay, S2 goes down for some reason, right? Well, what does that really mean? It really means this, right? It really means that your whole app isn't working. So S2, if it does some critical job, well, it's stopping S3 from working properly, which is also stopping the app from working properly, right? So once you start to get these service interdependencies, things become a lot harder to diagnose. I guess one of the things here, is like when you look at things like this in production or in an integration environment and you don't know a lot, you wouldn't really know what the root cause is unless you could actually get a good picture of this graph. One of the things that we notice as well is that service graphs, once you start to get like good velocity, is that they increase a lot. You tend to get like a few services at the beginning, and then all of a sudden your teams become proficient in making services, and then all of a sudden you get this like big explosion of services, right? And each team is working in their own little silo, so they don't really communicate, oh, well, we have this new service that's going out today. All you guys should watch out, it might affect production, right? Like that communication doesn't really happen once you get like great velocity. And then you probably end up with something like this. It's kind of hard to see, but this is an actually generated anonymized Hootsuite service graph. So we have 21 services on here, and you can imagine that if something went wrong, it'd be kind of hard to figure out exactly what it was. Sure, you'd get alerts and stuff, but the alerts might not tell you what the root cause is, especially if it's something lower in the graph that is affecting other services. So now we'll go back to that service graph again in a little bit here, but now I want to talk about an API that we use, or that we designed at Hootsuite to help with this visibility problem. So why an API first? Well, obviously it's language agnostic, so as we change to different languages over time, we can still implement this API and we can keep any tooling around that we built. At Hootsuite, we started with PHP and now we're using Scala, so there again is another great reason we can implement this API in different languages and we still get the great tooling. So let's go into a little bit more talking about the API, but before we talk about the API, we kind of have to define one thing. So at Hootsuite, we think of a dependency in our service graph as something that a service needs to function properly. So if you have a service, if you see on the right-hand side here, we have an app, and it has 3 dependencies. We break those dependencies up into 2 types. We say that there's an internal type, so think something that this service cares only, or that only this service cares about, nobody else cares about, and things that are traversable. So an example of things that this service cares about are its DB and its cache, and S1 is another service, so that is traversable as well. You could put S1 up at the top of the level of the app in this diagram, and it would have its own dependencies, possibly internal dependencies and traversable dependencies. So the very first API endpoint that we wanted to implement to help with visibility is about endpoint. I don't think there's any magic here, but the idea here is that it answers a lot of these who, what, where, when, why questions. So if you ever need to know what a service is or what it's composed of, you can always go to the status about page. But we also wanted to get this closer to being almost documentation-like as well. So if you don't know what this service does and you're kind of looking at this endpoint, you can find out, okay, well, what does this service do? How does it do its job? Who owns this service? Where can I find more info about this service, like code, logging, statistics? And if it's down, you can use this endpoint or output from this endpoint to figure out why it isn't working properly. So if an internal dependency is down, you can call this, and you will actually see a list of all its dependencies, what's up and what's down. Obviously, if the service isn't up, you're not going to get an answer from it, but if it is, you can learn about it. When we built our API, we wanted it to be similar to almost like an MVC framework in the sense that as you spin up a service, you register dependencies with our framework. And so as you register a dependency, your dependency then becomes available as a status endpoint. So in the previous example, we talked about a database, for example. So you can see status/db. That would be like an example of an endpoint which is registered in the system and then becomes available and can answer okay if the dependency itself is okay, or it can answer with an error message if something is wrong. Again, nothing really groundbreaking here, but the idea is that we wanted the platform to handle this, and you would basically just register your dependencies and then they automatically become available. The top one there, Service Core, is an example of what you might have for another service. So one of the other endpoints that we created is an aggregate endpoint. And the idea of this endpoint is that we wanted to create a simple endpoint that we could integrate with pretty much any monitoring framework. And that way we can set up, basically everybody knows how to integrate with a monitoring framework. They use this endpoint. This endpoint responds back only with OK or the very first error. So if you have a service and it has like 3 dependencies in it, this endpoint will check every dependency, make sure that they're okay. If they're all okay, it will just return back okay. If any of them fail, it will return one of the errors back. We have 3 error levels. We have okay, well, we have 3 response levels. We have okay, we have warning, and we have critical. If you have an okay, a warn, and a critical, it will return the critical first. If you have a warn, it will return the warn. If nothing, it will return okay. So it's pretty easy to get like a holistic experience just by calling this, am I okay? You know, it kind of makes sense, right? The next one, and I think kind of the funnest one, is the traverse action. So we allow you to call into any node at the graph and traverse to any other node below it in the graph. And this is interesting because it actually allows you to test your pathways of your application. So if we look at the right example here, we have an application and there's 4 services. Each one of the nodes in the service implements this traverse API. And what the traverse API does is it takes a set of edges and will traverse down to the last set of the last node in the edge. And then it will allow you to call an action. So we have defined right now the only action is about. So you can basically traverse all the way down to the bottom level of your service graph, and you can call about. So you can get the information about the service, and you can get the status of the service, because the about endpoint checks all the dependencies and returns their status. So this is kind of cool because you can now automate entering from a top level in your graph and going to any other point in your graph and then doing things. So we'll just go over some brief usage here. I kind of talked about a little bit, but since it's an API, I mean, you can really make awesome things, right? You can build tons of tooling over top of it, and I'll give you some examples of some of the things that we've built. So the very first one is monitoring. Again, we use a tool called Sensu. We also use another tool called Site 24/7. We can basically hit our aggregate endpoint, and we can get easy monitoring and alerting for the service itself. We can debug. So we can reason about a node in the graph because we can call the about endpoint. We can understand what the dependencies are, what the service does, and you can get error messages if things are down. Some other things that you might want to do here are, can I actually, so you have a new service and you're bringing this service into an integration environment. Does it work? Like, can it connect to the graph? So the very first thing you'd want to do before actually maybe even writing your code and actually calling endpoints is just connect it to the graph and make sure that all the pathways exist, and that security groups or other those things are all okay. Some other questions you might ask are, is our database available? Is this service running? Again, this uses the real application connections, which I think is a cool thing. So you can explore and learn. So if we go back to this kind of like more contrived, a little bit more complicated example, if you were given this application, just using the API, you could curl a bunch of different requests and you could kind of traverse down to different nodes and you could explore, right? That's pretty cool. And you can document. This is one of the other things, because we try and get a bunch of information into our about endpoint that's really like links to code, links to logging, links to statistics, like real-time graphite boards so you can see how your service is performing, links to ops runbooks and all that kind of stuff. So you can actually basically traverse down to a service, figure out a bunch of information about the service, and you can automate things like actually creating service graphs. So if we go, let me go back over here. It's kind of blurry, but so this is basically our service graph is being automated using that API since January of this year. It's anonymized data, but basically you can see the graph changing. So as people are going and adding services to our environment, our graph keeps changing. Imagine if you had to go and like manually create this graph all the time, that would be annoying. So we actually go and every night we run a script which goes and crawls our graph, and then goes and checks this into source control so that we have, over time, all of these diagrams. You can even do cooler stuff than this. Because you've gone and embedded links inside your about endpoints, you can actually create static documentation like Confluence pages and all that kind of stuff where people can go and get an exact representation of your service graph right now. So if any of your tooling goes down in production and you can't actually access some of the stuff that I'm going to show you later, you can always go back to a static version, which is always as good as today, and kind of debug from there. Those are kind of like worst case scenarios. So now we'll talk a little bit. I lost my mouse again, there we go. Talk a little bit about our monitoring strategy. So like I said before, we use Sensu for monitoring. And basically, from the services perspective, the only thing that Sensu does is basically call it aggregate. So everybody configures their service monitoring exactly the same from the ops point of view. From the developer point of view, like I mentioned before, you register your status endpoints. So you as a service developer understand what your service does, right? You understand if you have a database. You understand that you use cache. So you basically, using our framework, register your dependencies, and you let the framework take care of the rest. So when you go into staging and into production, you don't really have to do anything fancy. Like I said, you just look at aggregate. Sensu also does a bunch of other things. It sends alerts and notifications when things go down, but it also looks at system statistics, things like RAM and CPU and stuff like that. So if you have a microservice and that microservice has 2 or 3 worker nodes, one of those worker nodes may go down, so you may start getting alerts about one worker node, but that doesn't mean your whole service is down, right? So it's a pretty interesting thing to differentiate between the status of like a single machine in your whole production infrastructure or your application as a whole. So this API allows us to reason about the application as a whole, and so we created a tool that we call Voltron, which basically sits on top of everything like that and consumes this API and gives a user interface and allows people to drill down to different levels of the application in real time and see what they are and how they're working. So what is the Voltron app? The app itself is built with React at the front end and WebSockets, and then in the back end it uses Play and Akka. So it's basically kind of the architecture kind of looks like this. So you have a whole bunch of browsers or consumers that are basically using the tool to monitor something in a browser. So for every browser there in the back end, there is an actor which spins up, which holds the state for that user and connects a WebSocket to the back end. We have a polling actor, which is a single actor, which is its responsibility is to actually make requests to the service graph on behalf of the clients of the application. So if you think about the pathway that would happen here is the browser would come and make a request to the application, the WebSocket would connect, it would pass its state down and say, I'm looking at this thing. The status poller would say, okay, well, I'll start listening to that thing. Then when it gets responses back, it passes them back up to every actor that cares, which then passes them back up to the UI. So the kind of cool thing here is that because we're using events, everything's in sync. If people are debugging an issue, they're all looking at the exact same UI. It's unlike if you used Ajax or something like that, you could have race conditions and people could see different views. Here we're always in sync, which I think is a really big plus. So I'll go into a quick demo here of the app now. So a user of this app would come to this page. They can decide to enter into a service graph at any point. Because every node in the graph actually implements this API, you can enter at any point. But most of the time, we just enter from the top point of the service graph. So I have set up on my machine here a demo app that has a bunch of microservices attached to it. And the first thing I'd like to do is just explore that with you so you guys we can learn about the application itself. So let's kind of like zoom in. So the first thing I want to call out here kind of on the top is these here are different points in time that this app has gone and actually checked to see the status. So as you're exploring, what sort of things would you want to look at? Obviously, let's find out what this application does. So this is just a demo app for the conference. But we can tell, okay, so if something were to go wrong, we know who the owner is, right? So we have a point of contact. That's great. We can get directly to documentation. So if you wanted to learn more, like deep dive into this app, like what the application does, you could do that here. You can go directly to the code. You can get logging information and statistics, like I was saying. And you can also see what the dependencies are. So this is kind of where it gets interesting. So on the left, we have our internal dependencies. So this app looks like it has, it's using Memcache and MySQL. On the right, we notice that it has some service dependencies. And you can see kind of this icon here differentiating that you can, that there's more in the graph there. So let's, so here we have an app, 2 microservices, and this app also uses these internal dependencies. So let's actually look and see what service 1's all about. So you can go into service 1 and also look at it. Okay, so service 1, again, just a demo service, nothing really exciting here. But you can see an owner, again, more of that information, and then you can see, okay, well, this one uses Mongo, right? So that's kind of interesting. So let's go back here. We can go into service 2. So service 2 is a little bit more interesting. It actually calls service 1 as well. So we can deep dive into service 1. So if you look at the top, you can see the breadcrumbs that we have there. Those are the edges in the graph that we're traversing when we're going down to different levels. So let's talk about this more from an example of the 2 kind of use cases I gave you at the beginning. So like one use case at the beginning was a developer, they've gone and they've merged their changes into an integration environment, and something's gone wrong. I'm just going to make a quick change here. So developers probably looking at some sort of a page. Oops. So developers probably looking at a page like this. They're looking at some build tool, right? So they've merged their code in. Oh no, my tests have failed, my tests have failed. So what we do is we gave them the ability to embed like a status widget into any application, so you can see the overall status of an application. That's what you're seeing, this red dot here. So the first thing they do is they'd see their tests are failed. Oh, these tests worked in dev, right? Like they shouldn't be failing here, so what's wrong? But they don't really know about all the services. So they can just click on this and then they can deep dive right in. They can see that a bunch of errors were happening, so let's click on one of these. Oh, okay, so service 2, looks like there's some sort of a failure here on the aggregate check. Oh, the database connection failed, it couldn't connect. So you can kind of zoom down here, you can see, oh, let's look into service 2 here. So I think one of the cool things here is you can start at the top and you can start to drill down and go down to the lowest level where you're seeing this error. So it looks like service 1 is okay, but in service 2 there was an error with Redis. So then they go and they debug and they figure that out. So then they're like, okay, well let's talk to ops and we'll get that connection restored. And so ops goes and restores the connection, and then we're back to green here. So that you do the same sort of thing in production, right? What happens if something in service 1 goes down? That's a little bit more interesting because service 1, like service 2 depends on service 1, right? So let's kind of like simulate something failing there as well. So I have the poller setting up. It polls every 5 seconds right now to get new statuses. That's what you're seeing it go on here. So okay, so we got something red, something's wrong again. So it looks like service 1 is having an issue and service 2 are having an issue. If we look at the error messages, we can start to see, okay, well service 1 looks like it's failing because its database timed out. Service 2 looks like it's failing because service 1 is failing. Okay, so let's try and deep dive. So here, if we go into service 2, we can see that it's failing, oh, because service 1's failing. Looks like the rest of it's okay. And we can deep dive into here. Okay, service 1 looks like it's the MongoDB, so we can talk to ops again and we can get that fixed. And then yeah, you should go back to green again. So then you can zoom back out and you can see that the rest of the things are resolving, right? So one of the other things I wanted to show was adding a new service to the graph, because this is like pretty common. So you're going through, like a team's going and creating a new service and they want to add it to the graph. So they go into whatever application is going to start using it, and they basically register it as a dependency in that application, and then it will just automatically join the graph. So I have, in the background here, I'll just add a new service. Oh, before we do that, actually. So like I mentioned before, you can enter into the graph at any level. Like you can, let's go back home here. You can, I've just been showing you entering at the top level of the graph, but pretend we have this service out there that we haven't connected to the graph yet, but we want to debug that service. So you either want to do this in dev or you want to do this in staging or production. You want to just see, okay, well, we deployed a new instance of it. Is it available? So I'm just going to connect to that service directly. So you can connect to the service directly in dev. So you can see, okay, well, this service uses an Aurora DB. You know, like I said before, you can find out who's managing it. This is another team. Get some information about it there. If you're just deploying this, maybe you don't have your database set up correctly, right? You don't have the connection there, so you'd see this error right away, and you could diagnose it before connecting to the graph or doing those types of things. So let me actually connect it into the graph, and we can see it show up there. So I'm going to go back into to the main application where we were, and so we've got service 1 and service 2 here. I'm going to insert, just connect it to the graph. Basically, all I'm doing is just in the back end here is just registering the status endpoint, and the next time it will just join the graph. So as you're going, you could think about this like, as I deploy my app into staging, this will just show up as being in the graph. So now you can see that service 3 is here on the right side, and you can deep dive into it like we did before. So I think that's it for the demo. So I wanted to kind of give you a little bit of perspective of like what different people in the organization, how they kind of like use it. So this is our VP of software development, and you know, his observation is whenever there's an issue in production, all of these people might be getting alerts, but they all do the same thing. They all go to this tool. They all use this tool to kind of get down to the lowest common denominator and figure out what's wrong. So everybody, it's really worked out well for us. We have this funny service that we use to make IDs called Snowflake, similar to kind of like what Twitter does, creates unique IDs. And in staging, for some reason, this service goes down all the time and causes everything to not work. And so this is like a real example of that integration issue, right? If you can't generate IDs, nothing works. And people sit there and they try to figure out what's working, but this really helped us be able to kind of get down to that lowest common denominator and figure out that that's what was making everything not work. Again, this is kind of just the drilling down thing, but when all of these people get on high alert, it's just nice to have like one single way for us to all kind of work together to get down to the root problem rather than all of these other people going on different tangents trying to solve an issue. It's really helped us narrow down and really focus to issues in production. And this is a kind of like a debugging statement that I talked about earlier. So you may have one service that's calling another service, and you think that it's actually not connecting and calling that service. So in the real code, for some reason, there's maybe a bug in your SDK, or there's a bug somewhere before you're doing some logging. So you think, oh, well, the request actually isn't making it to the service. I don't think it's hooked up properly. Well, Voltron will be able to verify that for you and just like, you know, be able to help you narrow down and say, okay, well, the request is actually getting to the service. Now let's like deep dive into the service and actually figure out what's wrong there rather than trying to look at the infrastructure. So what did we learn in this process? I think the biggest thing that we've learned over this time is that visibility really empowers. When your development team grows, there's so many people that have different responsibilities in the organization. And if someone's going and pushing code to production, they want to be able to feel like they have the tools and the understanding to figure out what's wrong if something in their code goes wrong. And it's a really helpless feeling when you go and you push something and you don't have that expertise. So this has really helped us kind of just provide more value because we can ship more often, have developers which are more confident and more willing to take risks, but then also be more confident in their risks, right? So as they're going to production, they can just really be happy. again, this has helped with our education in general. So as we've gone from a team with 2 or 3 services to a team with 21 services, people can actually go and understand the architecture at a pretty understandable level, and it changes often, and they can still understand it. And I think that's a really big win. So we didn't do this, I think, early enough. And I think that's part of the SOA game, is that as you kind of grow your services, you have to learn or else you won't be successful. And you have to automate everything, and you have to think about the tools that you want to do as early as possible. One thing I like to ask myself is, it's kind of like the 10 times factor. So if you look at your infrastructure now, and if you think if your infrastructure was 10 times bigger, if you had 10 times more services, how would you manage that? And if you don't think you can do that, then maybe you need to step back and try and think of tools that will help your team get there. Another one, just make status checking easy. I don't know if you have 5 teams and they're all building microservices. Each one would probably try and tackle how to check status differently. People do tend to solve problems differently. I think by just defining an API that people implement just really makes that easy. It makes it easy for you to step into anybody else's service and just understand what is there, and also how to debug it and how to set up monitoring for it. One of the other things that we did that I think was a big win for us was to share common status checks. So if you guys are using similar infrastructure components all the time, like for example, say you use MySQL all the time, or say you use Mongo all the time, just create a library that knows how to check Mongo, right? And then share that between all your teams. I think we have right now about between 8 and 10 different shared status checks that everybody can use, and we're kind of adding to that all the time. And it just makes it so that, there's when someone checks MySQL, they're checking it the same way all the time. It's not like you're going to have someone check it differently and then have issues come up because someone did it slightly differently, or they didn't catch this exception, or they didn't do this type of thing. And this is more around the tool, but I really think we had kind of 2 versions of the tool. We didn't go to WebSockets immediately. We started more with an AJAX polling method, and it was good for setting up the tool initially. But we did find that it caused a bunch of race conditions and a bunch of issues, kind of going into the stack and performance issues. So this was another real big win for us, just to go to this and just have everything synchronized. So what are we thinking next? We actually really love Voltron, and it's helped us a lot, but we still think it could be a lot better. So one of the things we're thinking is, you saw in the tool where it had the bars at the top, the history. That's kind of just application state. It's not being saved anywhere. So the monitoring tool gets turned off. That kind of goes into oblivion. We found that with Sensu as well, in the way that alerting works, it kind of just floods your inbox or your Slack, and it's hard to make reports and hard to go back in time and analyze kind of what the actual error messages were. So what we're thinking here is to try and put some of this in a database, and then we can do some basic analytics, like what are the most common error messages, what services are the most flaky, so which ones are going down more often, and that'll kind of just help us kind of optimize our graph, I think, a little bit better. Some other things you could do here is maybe calculate uptime, again, finding the most failing services, finding patterns. I think this would be cool too. Basically, you saw the animated GIF. What if we had a 100-foot view, basically this live heartbeat of that application, of the whole graph. So you could see kind of the request going through the graph and see red on there and see it propagate up. And lastly, we're thinking of possibly open sourcing this. Would there be any interest in the room from people? Would you be interested in using a tool like this? Yeah, there's a bit of interest here. Cool. That's it. So anybody have any questions? Yep.
much over time.
Yep.
Can you talk about sort of how that's managed in your organization, like how many teams you have, how many people on each team, what they're responsible for, how, you know, how the decision is made to kind of modify the architecture of the whole system?
Yeah, so at Hootsuite, I can go back to that one. I think I had all the teams laid out here. Yeah, it's all good. Yeah, so this is kind of the overall kind of like our breakup of teams. Again, each team is pretty autonomous. So it's not like when a team is like, oh, we're going to create a new service, they go and talk with all the other teams, right? Since we have the tooling in place, it's more that the team realizes they need to, you know, either ship a new feature or they're trying to take some code out of the monolith and kind of like make that into a service. And so they go and they do that. They figure out what other services they may need to use. So they would have some interaction with other teams. You know, like say your service needs to authorize, it might need to use some sort of an authorization service. Or say it needs to load members, you know, you might need to use a member service. So you'd kind of like figure that out. And then really what you do is you just, using our framework, you kind of just register dependencies, put yourself in the graph, and then you kind of just show up there. And our automated tooling goes and just adds you to that diagram, and then goes and adds you to our sort of like wiki pages that have information about the service. So it's not like you really coordinate in a really large way with the whole rest of the team, because your team is pretty autonomous. You really just kind of work in your team, and then the tooling kind of takes care of the rest there. But you're right, like there were a lot of changes there, and it does kind of, I guess it's just, the one takeaway there is that you don't really think about that often, you know what I mean? Like you don't really step back, I think, a lot and kind of look at your graph at how it's changing. And so being able for us to audit it like that is pretty cool. So we can go back in time and kind of see, oh, well, when did this service go into production? Oh, it looks like now it has a few consumers at this point, and that kind of stuff. Any other questions? Yeah?
If you open source, under what type of license would it be?
We haven't really talked about it a lot too much, just kind of wanted to see if there was any interest. It seems like there is, so we would kind of look at it a little bit there. But our open sourcing plan would probably be more about open sourcing just the API itself and maybe our implementation of some of the inner workings. So we did it in PHP and in Scala. And yeah, and then it would be great if the community could help us kind of do that in other languages. And then that would be awesome. And we could really kind of have more of a polyglot kind of service graph and be able to manage it with the same tools. Yeah, Ken? Okay. Cool, so probably Apache 2 then. Any other questions? Yeah, at the back?
So what about automatic root cause detection? It seems like you have to walk through the graph manually, get to the root cause.
Yeah, so that would be another interesting way to do it. When I was doing the demo, did you see how that some of the, like, for example, when we had an error in service 1, service 2 is actually showing the error of service 1? So we actually do bubble errors up the graph already. And you can just kind of click down and get down to the root cause there. So if you had multiple things that were kind of going wrong in a disaster, you might have to go through several different paths to find multiple things at the bottom of the graph that were going wrong. But you're right, you can do that, yeah.
Another question.
Yeah.
So each service, there was a particular time thing. What was that? Was it uptime of the service?
No, that was how long it took to actually check the dependency that it was checking. Yeah, so you can kind of like think about those as latency helpers as well. So if you notice one status check is taking a really long time, you could start to look into why that might be happening. We've had that happen before when we had load balancing issues, or we've had it happen before when databases just became slow. The interesting thing about the way that we've defined status checks is that status checks are really code that you write. So a status check can do whatever you want it to do. So if you wanted to check that you could write to a database, you could have that in your status check. If you wanted to check that you could read to a database, you could do that. So it could help you figure out, okay, well, writing is taking a really long time, or reading is taking a really long time, or those types of issues as well. Yep.
What kind of service discovery mechanism do you use?
So service discovery, so we are currently working towards a new kind of platform. In our old one, we don't really have great service discovery, but in the new one, I think we'll be using a tool with called Console, and using that for service discovery. Cool. Oh, a couple more, yeah.
Consider using Swagger or something to standard to document the API services, or you are doing?
We do have some of that, yeah. So we use Swagger a little bit internally. We've kind of liked it, but not. We've had some challenges because our old service infrastructure wasn't really, it wasn't built on HTTP. So we didn't get some of the really cool things that you get with Swagger, with being able to actually query it and stuff like that. But yeah, I mean, I think that's a really good thing. So you can automate the generation of your docs, and then you can have links in this in the about endpoints that basically point you to the docs, so you can automate building that into a real kind of homepage for your service.
So for now, we just do it in the log page, free text form in the log page for the endpoints.
No. So we do have API documentation. Yeah, but we're using a couple different tools internally. It's not just Swagger. But that about page would have a link to that documentation, yeah. Yep. So yeah, I mean, it can happen, and we have had it happen in the past. So one of the things is the tool, we don't restrict you into doing that. So if you want to do that, you can. But whatever tools you automate with, you have to be able to understand cycles then, because obviously you don't want to have infinite tooling there that's kind of running forever. So what we've done is when we've had to go back into the graph at another point where we actually effectively create a cycle, what we do is we just register that as a non-traversable dependency. So you would go back to the source. So you can imagine being at the top level of the app, maybe going down and then going back up to the top for some reason. We would just say that you can't traverse that. And that's really easy to do in the API. And then when you're actually traversing the graph, you can check to see if the dependency is traversable or not. It's not, and then you wouldn't be able to. Yep.
Do you have these services in multiple regions? And if so, how does that represent it?
So in the tool right now, we actually only do it, it's region by region basis. So the tool doesn't restrict anything to do with that. So if you actually had a top level load balancer that was, basically load balancing between the regions in some way, you could put it at that level, right? So you can enter kind of at any level in the graph. You would probably want to do it at a region basis, though, I think. I think that would make more sense. So you have an issue in a region, and then you would use the tool to diagnose in that region. Cool. Well, thanks a lot.
Thank you, Adam. The speaker for the next slot in the applications track has had a family emergency and will not be able to speak. So the next slot, there will be nobody in this room. I encourage you to head down to the systems track, or I guess it's up actually, up onto the 10th floor for the systems track to view the talk there, and we will be back in action, I believe, at 11:20 in this room here for the remainder of the applications track. So, thank you.